Good morning, everyone. My name is Joni Roinila, and I'm working at the Access Networks department in Teleste. And today I'm presenting a new Teleste product, VDM, Virtual Device Manager. And then I was also asked to present some use cases of our RPD nodes. But I kind of made it to have an overview on the current market momentum and how Teleste fits in that picture. There is probably some overlapping with the previous presentation. Let's go through them anyway. So this kind of similar picture that Salt was showing, this is from a vendor point of view, what we have seen, and as we are in continuous contact with different operators from all over the world, this is what we see at the moment. So most of the operators are still using these old big iron CMTSs, if you will, or even still analog fibers, or some DOCSIS 3.1 MAC5 proprietary solution. And now those big iron CMTSs are going end of life. Cisco has already publicly said that CBR8 is more or less finished. So now operators need to replace those in some time frame, and now we will have a look what are the different options for those kind of replacements. So from the bottom, we see these, what we have labeled as aggressive overbuilders. These are operators that are focusing on fiber and are just basically do nothing with the coax, just let it be slowly fade away. But of course, that still requires some maintenance for some years to come. And on the other end of the spectrum, we see this in DOCSIS we trust group. We see that as those operators are really directly competing with fiber. So the claim is DOCSIS can do what fiber can do. But of course, these DOCSIS 4 investments can be quite costly. So it is of course up to operator what you want to do. And there are different flavors of DOCSIS 4.0. We have this full duplex DOCSIS that is mainly Comcast in the United States. We are not really aware that anyone else is doing that, but Comcast is so big that they can have their own way. The industry flavor seems to be now this extended spectrum, so just extending the spectrum from 1.2 to 1.8 gig. And that is kind of a natural evolution if you think about DOCSIS. Of course, that is also quite heavy investment, but we don't see it as heavy as going this full duplex mode. Then in the middle, we have this interesting part, this mid-speed overbuilders, operators that are probably shifting to fiber at some point, but still want to give also cable customers good speeds. So then comes into play this DOCSIS 3.1 Plus. I think Salt's presentation covered that pretty well, and also why the industry is now moving to this virtualized CCAP, so I won't bother you with that. But anyhow, now this middle part here is especially where Teleste is a strong player at the moment, because these big iron CMTSs needs to be replaced. So our message at Teleste from day one has been that we will be the best partner in an open ecosystem environment, meaning operator can choose their CCAP core from any of the available vendor, and Teleste RPD will work with that one. It doesn't matter what core you are using, the Teleste RPD will work with that. And that has been our promise, and we have been successful with that. And as it says here, we have live installations with basically all of the major core vendors. And we also have all the CCAP cores in our lab, and we continuously do these interop verifications. And on top of that, we also attend these cable labs events in the United States. And the picture here shows a quite typical installation, what is done these days. So there's a separate DOCSIS core that can come from vendor A, there's a separate core handling video that can come from a different vendor. And then there could be some other auxiliary cores for, I don't know, monitoring purposes, handling out of band, and that can also be from a different vendor. So this is really what we are highlighting all the time, that no matter what you choose, the Teleste RPD will fit in that picture. And there are some selected public references. We have Liberty Global and its subsidiaries, as well as Telia Group, mainly in the Nordics. And then I have this slide showing the importance of interoperability and what we claim is working with our RPDs. Now you see this one new player in the core market, Vesima. It was announced by Cox Communications, a big North American operator, that they have selected Vesima as their vCMTS vendor. So we see that Vesima is coming strongly to the core market. So of course we want to do some interoperability with them, and we actually have tested our RPD against the Vesima vCMTS at this Cable Labs event in the USA. And it's more or less working already, because both are operating according to the Cable Labs specifications, so it's quite a smooth sailing, but we are still looking to get that one also in our lab. That's a short, let's say, market update and how Teleste is navigating through these situations. And now for this main presentation, I'm introducing this VDM Virtual Device Manager. Background for this product is that this telemetry solutions in cable networks, quite often DOCSIS-based transponders have been used and are still used. But those are now going also largely end of life and obsolete. So that is a global problem, not only for Teleste, that those DOCSIS transponders are simply not available anymore. And then there are these legacy CMTS systems, for example, our HDM 100, so the telemetry is based on HMS. And now, as the industry is moving forward, everything is getting virtualized, and we want to get rid of all hardware-based specific products. So it's quite natural to also virtualize this HMS controller. HMS is an old standard. It's well proven to be working, and Teleste has been manufacturing this HMS devices also for quite some time already. So for us, it's a natural evolution to virtualize this one as well. So the giveaway here, I think, is the bandwidth actually of this FSK link. So now that we are moving to distributed access systems, we need to find some way to transmit these analog signals. And now we have to use these narrow digital forward and narrow digital return channels. So we have been utilizing now this mode 2 or 320 kilohertz channel to transmit this FSK link. There are, of course, wider channels available in the specification, but that is just wasted bandwidth. So that mode 2 or 320 kilohertz is the sweet spot for this kind of application. There is some legacy HDMS. In this case, I have pictured this Teleste HDM 100. But then, since we are now in distributed access, we somehow have to transmit that analog signal. And currently, as far as we understand, the only way has been to use this out-of-band gateway. For example, Cronbach NDX. I'm not sure if there are any other out-of-band gateways in the market, but at least that Cronbach NDX is being widely used. While this is a working solution, it works, but there are some issues and limitations. Of course, scaling is one topic, since we need to get this special hardware not only for the HDM, but we need this out-of-band gateway as well. So this is all still dedicated special hardware, and at least our HDM is going end of life at some point. So how we are then tackling this, or how the VDM fits into this picture, is so that we replace the HDM 100 as well as the out-of-band gateway with this VDM solution. So it's one typical server, and we only provide the software for that. And with this solution, we can get rid of the scaling issues and all the configuration issues. So in this solution, this VDM will act as an auxiliary core towards the RPDs. So the VDM itself will provide all the necessary configuration for the RPDs. So again, in this situation, it doesn't matter what CMTS or CCAP you are using for your other services like DOCSIS or video. Those cores are not even aware necessarily that there is this VDM, because this VDM acts as an independent auxiliary core. So that is really handy in this. So how this works is that this VDM configures NDF, NDR channels for the RPD, and then those are transmitted in this L2TP channel through the SYN network for the RPD node. And then the RPD node generates the physical FSK link for the amplifiers. And then I have here this data center pictured that then typically talks directly with the amps, for example, with SNMP. Here is how the VDM is then actually connected to the network. So there are two physical ports are needed. In this picture, this Ethernet 0, labeled as the SYN side link or southbound interface, that is connected to the RPDs. That port can be either IPv6 or IPv4. We support both, it doesn't matter. And then behind the RPDs, we have this, what we call HFC subnet. So that is basically where the transponders are then residing. And those transponders then talk directly through this link for the management system. So like this. And also the transponders itself, those can be also either IPv6 or IPv4. So both are supported. But what is required are two physical interfaces, preferably 10 gigabit Ethernet for both. I have actually more detailed slides on the requirements here. This is what we recommend for the hardware, and the limiting factor in this system is really this number of unique NDR streams. It's not really about how many transponders you will have in the network. That is not the limiting factor, but the limiting factor is how many unique NDR streams you're going to have. So basically, easy example, if you are using 1x1 RPDs, so one downstream, one upstream service groups, then there's naturally one NDR going up. If you are using 1x2, you probably have two NDR streams going up from the RPD. So the number of NDRs is indeed the limiting factor in this one, and this slide basically just shows what we are recommending from different scales of installations. It is of course up for the operator to then decide what is the optimal solution for them. A little bit more on the requirements. We currently support Red Hat and Ubuntu. Those are officially supported here, and as said, we need some dedicated server, hardware, or virtual machine for this VDM. And two physical ports, as said, the SYN side port needs to be 10 gigabit Ethernet. We also recommend that the northbound facing port is also 10 gigabit, but 1 gigabit will also manage, at least in smaller installations. Then what you need is obviously some sort of IP address block, whether it's IPv6, IPv4, it's up to you. And then during the installation, VDM will download some necessary applications. That's basically how the VDM is designed and what it's used for, so amplifier control in distributed access networks. Then as we have showed this idea to some operators, we have had this request that, okay, it sounds very interesting, but we are still in analog network, but we want to utilize this system. Is that possible? So we have then came up with this new solution. It is still the same software VDM, but used a little bit differently. And here is how this can be used in these legacy analog networks. So the situation may be that the operator is now running an analog network with DOCSIS transponders, but as said, the DOCSIS transponders are going end of life. So what can the operator do? Well, you can utilize this VDM as a principal core. So in this type of use case, we will bring the VDM into the network along with couple RPD nodes or RPD shelves, it doesn't matter. And then we basically feed the FSK signal to the analog network. So this can be also utilized in these legacy type of networks if needed. This has been requested from some operators, and this is quite handy because, of course, the old DOCSIS transponders can still coexist in the same network. So those DOCSIS transponders will then talk with the CMTS, and your HMS transponders will talk with the VDM, and both can be then coupled, for example, Teleste Argus management system or some other third-party management system. Little bit more about this special case in analog networks. This, although I have been preaching about this interoperability and open environment and all that, but in this type of installation, we kind of have to make some modifications that will break the general rules of the cable labs specification. So in this use case, this will work at least so far only with the Teleste RPDs. But in this environment, then it's sort of a closed environment, so that VDM will be the principal core towards the RPD, and it will give the NDF NDR configuration. We have made this simple because typically you would need this PTP, etc. So now we have made modifications that this can work without timing. We don't need PTP in this kind of installation, or any external provisioning for that matter. All the operator needs to do is give the IP address of the VDM for the RPDs. I still wanted to include this screenshot from our press release a month ago or so, that this VDM is now available on the market, and the beauty of these software tools is that it's very easy to distribute and scale. So if you want to give it a try, it's freely available for 60 days evaluation license, and if you like it, we can discuss more about it. Okay, thank you.